The day ChatGPT came out was revolutionary to everything. Everybody looked at, we used to Google. Then, I think it was first week of ChatGPT, hey, do me a favor and create a song in Tupac's voice, but the way that the president speaks. And then you saw that one clip came out. Wait a minute, that's amazing. ChatGPT, I want you to take this research, and then all this data started coming out. And like this, things have changed. 2-3 years, however long it's been. How quickly do you think we're going to have new advancement the next 5, 10, 20 years that will be just as shocking as OpenAI?
I'm super excited about how, these language models, these basically like LLMs, and how AI is going to help really advance science, and particularly science in the field of aging. Because at the end of the day, you can do everything in your capacity with your diet and your lifestyle to really give yourself that, edge in terms of like aging better and living longer. But at the end of the day, you do have a certain genetic potential. Like you could eat, healthy and exercise and still not live to be 120, right? There is a genetic component to living to be 100.
Eat healthy and exercise and still not live to 100.
Living to 100, believe it or not, is largely genetic.
Okay.
But that doesn't mean that, diet and lifestyle don't matter. They matter a great deal. It's a matter of, basically your quality of life and not having Alzheimer's disease and cardiovascular disease and type 2 diabetes and things like that later in life, really degrading the quality of your life and perhaps giving you an extra 5 years, right? But you're not going to live 25, 30 years more by just being healthy, right? So this is where gene engineering comes in. And that's where I think the AI also comes in, because it's really going to, I think, exponentially move that field forward. Whereas it's been kind of like, it's been progressing, but at a pretty slow rate. And so,
what do you think we'll see? Like, give me 3 things you'll say, these are 3 crazy, wild things we may see.
Yeah. So there's this, you've heard of stem cells, right?
Of course.
And have you heard of, do you know who Shinya Yamanaka is, the Japanese scientist? He won the Nobel Prize in 2006 for basically discovering that you could take any cell from a person, an 80-year-old person, an old cell. We're constantly getting, skin cells are falling off our body constantly. You can take some of those old skin cells from an 80-year-old woman, for example, and you could put 4 different, what are called transcription factors. It's basically just, a gene that basically is a master regulator of many, many different genes. So it activates genes, or it, silences them so they're not active. And you could put 4 of them on this skin cell, okay? And you could revert that skin cell into what's called a pluripotent stem cell. So that would be a cell that could become pretty much any type of cell in the body. And so this is induced pluripotent stem cells, and this is what Dr. Yamanaka won the Nobel Prize for, because it's really the ultimate reversal of aging. If you take an old cell and turn it into a stem cell that can become any type of cell, or neuron, an eye cell, a heart cell, right? But so this is where it gets really exciting. You don't want to if you want to reverse aging, you don't want the cell to lose its identity, right? You want to take a cell and reverse its aging, but keep it that same cell, right? So I just told you the skin cell becomes a stem cell, and then it can become any type of cell. So now we have some new data. This is all animal data, where you can basically take this old skin cell and just kind of pulse those 4 different, those big genes, those transcription factors on the skin cell, and you can epigenetically wipe out. So epigenetics is like those factors that are sitting on top of our DNA, like, methyl groups, and they're activating genes or deactivating them. You can wipe them out and make the cell young, but still keep its identity. And this has been done in animals, so essentially reversing the aging. No one's been able to, there's a lot of hurdles to overcome in terms of like, how do we get this into humans? The delivery system is kind of questionable, because what they're doing in animals is giving it this virus, and it's like, well, the virus could potentially integrate into the genome and maybe be oncogenic. So there's a lot of things to overcome before it goes to humans, and I think that's where AI is going to come in and help us figure out how we can translate this data into humans. And I don't know if that made sense to you, but it's kind of this futurism type of stuff, but it's very exciting.
It is. So, but I guess what I want to go more to is I watched a movie yesterday, Saturday, called Mercy. Just came out with Chris Pratt. And it's like, it's one of these movies. What was that movie back in the days where it could predict somebody committing a future crime? Minority Report. And Chris Pratt, who's a cop, comes in, and this software, this judge is AI. Her name is Mercy. And he comes in, and all of a sudden, he wakes up. He doesn't know what's going on. And Mercy says, you just killed your wife, and you stabbed your wife XYZ times. Like, wait, what? I would never do this. And the AI convinces him that he did. And then eventually, you have 90 minutes to make the argument that you didn't do this. So pull up this file, and put up that file, and pull up. You become the lawyer for yourself. Very interesting, futuristic. And the way it ended, the story, I'm not going to tell you what it ended, but the line that he says, here's what we learned, that both humans and AI can make mistakes. Yeah. But when you watch it, it was kind of like, man, this is very realistic. We can get here very soon. For the average individual, if you say, okay, what are some things people want to do? We want to live a healthy life, enjoy it, live long, pain-free, right? Enjoy ourselves to the point where, I can still move my body in my 90s, in my 80s, maybe make it to 100s. What massive, resounding, innovation could happen that'll shock everybody? Is there anything? Because we've heard about stem cells, right? We've heard about stem cells. I went to Beverly Hills. One of our clients invited me. I got 80 million stem cells in my back. They said, this is going to fix your lower back problem. Nothing happened. Is there anything that you think could happen that's revolutionary?
Well, I think that stem cells could be part of that, I would say, equation. Mm-hmm. So we can have, stem cells then that are tuning up every organ in our body, right? And not just for regeneration or recovery, but also we can grow organs. Like that's a new thing where scientists are now growing, like even 3D printing human organs. And so it's like, oh, your heart's giving out. We're going to grow a new organ. It's from your own mm-hmm. cells. So you're not going to have that rejection, that rejection type of phenotype that happens. So this organ regrowing thing is really cool, where you're basically going to get a tune-up. Oh, I need a new liver. It's not working. At the end of the day, I need to inject some neural stem cells in my brain because I'm losing, my brain's atrophying. I'm losing cells in my brain. So I do think that's all on the horizon.
Can that be measurable? Like, can it be done in a way where I instantly can see results? Like, let's just say, systems attached to my brain, and it says, okay, what we just did, it took you from this number to this number. Look where you're at now, just by doing this test. Instead of, it could work 52% of the time it works. Like, will there be things that I know for a fact will work?
Well, if you're looking at, for example, brain mass, yes. I mean, if you see that you're injecting stem cells and now you're growing new neurons in the hippocampus, part of your brain, which is involved with learning and memory, then that would be something that you can measure. By the way, exercise can regrow brain cells in your hippocampus as well. So that's one of the things that we do have mm-hmm. control over right now. Mm-hmm. Yeah. We can talk about that. But and then gene therapy. So like we do know there are a variety of what are called longevity genes. Like these are genes that are found in people that live to be 100. So these are centenarians. Or semi-super centenarians. So these are people that live to be 105. Or the super centenarians. So these are people that live to be 110 and older. There's a common denominator of really highly active genes that are found in these individuals. And these genes happen to be genes that are involved in basically the cellular stress response, which is essentially when you stress your body adapts and responds and goes, uh-oh, there's stress going on. I need to respond to this so that I can stay alive. And it does things like increases antioxidant genes or anti-inflammatory genes or genes involved in making stem cells. All kinds of these like stress response genes are really highly active in people that actually do live to be 100 plus. Mm-hmm. And so gene therapy can then deliver those genes to the right organs in humans. And then again, you'll be able to, now deal with the stresses of aging better. And I think that's another thing on the horizon. So for example, Dr. George Church, he's really the godfather of gene engineering, played a role in discovering the human genome. He's done studies in rodents, in mice, where they took, 3 or 4 genes and made them, soluble, injected them in mice, and it extended their life expectancy. It reversed aging of their organs. He's now doing clinical studies in dogs. It's much easier to get FDA approval to do these sort of things in dogs than humans. But it's like, once you get to the dogs, you have humans that are like, of course, I want my dog to live longer. And so they're going to, start to approve those sort of therapies for dogs. And then it's easier to then start them in humans. So I think, again, AI is going to play a role in getting some of these gene therapies from bench side, from, this preclinical data into humans. And all this is super exciting because.
Oh, I'm excited. And my optimism is the fact that you guys are going to figure things out. That's what I'm relying on. I think the speed of using AI and gene. What was that one company video that we saw? Was it CRISPR? Was it called CRISPR? Was it called CRISPR?
Yeah, CRISPR.
So is that kind of what you're talking about? That's the direction we could be going?
CRISPR is one of the directions. So gene therapy versus gene editing. So gene editing would be CRISPR. That's a technology that's used to change just like a single nucleotide of DNA, which can change the function of a gene. So for example, some people have, these variations in our genes that make us not have them work as good.
Mm-hmm.
Some people have diseases because of it, right? Cystic fibrosis being one, right? Muscular dystrophy, right? Things like that, where you have just a little one nucleotide or two nucleotide change in a gene and it completely alters the function. So CRISPR can come in and actually change that gene. So you can basically take someone who has a disease and completely wipe that disease out and reverse it so they don't have it anymore. Or perhaps you can alter the DNA of a gene and make it work better. Gene therapy is where you're basically just putting more of a gene there. So let's say we have these longevity genes, for example, FOXO3 being one. This is a major transcription factor. Again, it's regulating multiple genes involved in everything I just said. Antioxidant production, anti-inflammatory production, stem cell production, all these things, the response to all kinds of different stressors that happens throughout our life as we age. And you're basically able to handle that stress better. So what you do with gene therapy is just give you a boost. You get a boost more of that gene that's going to make everything else work better, kind of like a genetic tune-up. Mm-hmm. So there's a little bit of difference between gene therapy and gene editing, and I think they can both work. And it really depends. It'll be more of an individual, sort of personalized type of approach because we have different genetic makeups and we have different benefits and there's things that we aren't as good at depending on our genetic makeup, right? And so. It's really kind of cool, all this tuning up you can get.
It is. And I think I saw an article a few months ago where it said, there's going to be a time we can go in and say, I'd want my daughter to be 5'11". I want her to have blonde hair. I want her to have blue eyes. Will we get to a point that people would choose what their kids are going to look like? Because that's pretty scary if you can get to that point.
Well, that's the ethical question because, yes, you could potentially do that with the gene editing technology and CRISPR and some of the other types of technology that come out and a little bit more precise that are part of CRISPR. I think that, right now, think about IVF, right? You go and people, they're getting screening. You're screening for genetic diseases. If an embryo has a disease,
right.
You don't do it. So at a certain point, it's like, where do you draw the line? Okay, well, I don't want my child to have cystic fibrosis. Okay, well, that's acceptable, right? Because that's like obviously.
But that's the risk versus this is exactly what I want him to look like. Right.
Right. That's where it's like, well, what if you want to make an embryo that is smarter, that is more resilient to disease? These things are probably going to be more acceptable in the community than phenotypes, than looks, right? So it's like it's hard. It's like this blurry line, and what's ethical, what's not, and how do you define that? And it's going to be hard. There's going to be all sorts of questions, and I would say problems that are going to arise as this technology advances. And it is very exciting, right? You're talking about what if we could tune up humans where we're smarter, we're more disease resistant, we live longer. Who doesn't want that?
What would you take? What would you do? You're in this world. Like, what would you want to see? Because for me, when I think about, kids, what you would want it to look like, what you would, how smart you would want them to be, then it gets me to go think about, the whole, I don't know if you saw the article came out last week about Chinese billionaires doing birth tourism and dropping off surrogates with hundreds of girls and, hey, I want you to go to U.S., become a citizen, then come back in. Okay, so now let's take it even further. And then now we're making superhumans, 150 IQ, strong, they can jump 48 inches. And, what does the world look like in 50, 100 years if we're able to do that?
Right. It's a really good question, not to mention the fact that, if you start to screen for intelligence and like, how do you define intelligent, right? Because we have this like neurodivergence, people are so different and some people are very analytical. You have that engineering type of brain, and then you have the more conspiracy type and maybe a little more paranoid, but those people also play a role in society. And they can connect the dots real easy, and maybe sometimes they're making conclusions that might be not correct, but sometimes they find things that people that are really super, super analytical don't. And so it's a good question because, like, then you have to ask yourself, like, well, am I screening for a certain personality type, and how is that going to change society, right? I mean, because it's hard to draw that line, and I know we're getting into these crazy ethical questions. At the end of the day, I'm excited about healthier living. I'm excited about, like intelligence. Again, how do you define intelligence? Like, that's a whole other question. We do know some genes that are involved in intelligence. One actually is called Klotho, and that gene is also involved in living longer and protecting against Alzheimer's disease. So it's very interesting. Some people have different variations of that gene that makes it more active, and those individuals don't get Alzheimer's disease. They do have a higher IQ. They are smarter, and they live longer. And so, there is an initiative now for some researchers that are really trying to make a type of Klotho that people can sort of inject and take and get to the brain and help protect them from Alzheimer's disease, help, make them live longer, perhaps be a little smarter. And that's actually research that's going on right now. So, it's not like this stuff is like totally futurism stuff. This is research that's happening now. And I do think that with the help of AI, it will advance it. With that said, you said something that I think is key, and that is AI makes mistakes. And I can't emphasize that enough. And certainly with each model that has come out, over the past couple of years, it's gotten better, especially if we're talking about the science, the field of science and research. But I will say this, it depends a lot on your prompt, what your input you're putting in, because what I've noticed about AI is it also likes to kind of appease you. And so if you
more it
bias
listens to you. That's right.
You
Yes.
bias it a certain way with the way you're asking a question, you might get a very different answer, and I've tested this. It also depends on the model that you're using. I think that the free models don't ask science or research questions. It's not going to be accurate. If you're wanting to actually get a science, really evidence-based, answer, you have to have the paid version for one, and really a deep research. And that's something that's able to go out and look at the scientific literature. And that is something that I would trust much more than just using like a GPT 5.2 free, version of it. So I'll say that. I'll leave it at that, because you can definitely get wrong answers when it comes to asking a science-based or medicine-based question.
Yesterday, my CTO came to me and says, hey, look, they measure every month which language learning model is the most accurate. And right now, for the last month, he was showing me that Gemini is at the top at 38.5% accuracy versus a lot of other things. So even till today, it's still making mistakes, and they're openly saying, we don't know it all. We are making mistakes. But, in regards to brain, right, the way we think, back in the days, or maybe even still today, we would say, oh, my God, he's got a photographic memory. He just remember. How do you remember that? How do you read a book and you retain so much of it, right? How impressive will that be in 10 years, 20 years, where we can all, people choose to put a Wikipedia in here, all the facts that are in the world, the facts, like the day you were born, the day I was born, the day, World War II, or such and such person died, or this happened. Once that's in there, what do you think will be impressive in 20, 30 years with human beings? What will we look at and say, man, she's pretty impressive, he's impressive? What will impress us?
I know. It's an interesting thought experiment, because it might be something that is unexpected and surprising, like more just empathy or human qualities or arts, or being able to make something really creative that you're not really going to be able to do with the AI, right? I don't know. Or like being able to sing a beautiful song. Like AI can make that music. You're talking about Tupac. And
right.
I mean, my husband and I make AI music for my son to help him. He's been learning Mandarin. And it's like amazing. Like the music that AI can make, it's almost frightening, because you might go, wow, like, what's going to happen to the music industry?
Yes.
But I do think that at the end of the day, what's going to happen is, as we get more, advanced with AI, and as you mentioned, perhaps we do become smarter, maybe through gene engineering and all sorts of other techniques and advancements, I think it's going to go back to the human condition, and that's going to be more impressive. I think I don't know, that's just a guess.
What do you mean by human condition?
I mean, the arts and empathy and just, being creative and creating something that you're not going to be able to get with just facts, right?
Yeah, I guess in bodybuilding, they'll say, This is the natural Mr. Olympia competition, right? They put nothing in their body. And this is open. This guy is, you can use anything and everything, and he's the Mr. Olympia champion. I wonder if we're going to get to even today, I think we have an Olympic Games today that they're talking about called the Enhanced Games or something. I don't know. Have you heard about the Enhanced Games? It's literally called Enhanced Games. And in this Enhanced Games, they encourage you to do PED. Everybody's on PED. And just let's find out what does it look like if we're freely able to use everything, right? So I wonder if it's going to be like, he naturally looks like that. That's natural beauty. She's done no surgeries. He's done no surgeries. He hasn't put the stuff in his brain to be interested in what he has to say. Or else podcasts are going to be what? Then are we going to watch AI podcasts? Is there going to be two personalities like Gemini's? Mary is doing a podcast with OpenAI's Bobby, and they're debating politics. And we can program one to be a leftist, one to be a conservative, and go ahead and debate this issue and state the facts. Will we be going there, or are we going to be like, man, I would much rather listen to these guys because they're regular human beings making mistakes? And is it going to be attractive to be dumb? Is it going to be attractive to make, dumb comments? I really wonder what's going to happen in 20, 30 years. Because it's going to be a commodity if you're smart. So what? I can have the same thing you have. I just put a chip in my head. You're no longer competitive to me. So why go study? Like, we would hear people say, I knew how to study for 2 days, memorize everything, go ace the test, and forgot all of it, right? And that's what college is really all about. I really wonder what's going to happen and what will we be turned on to? Mistakes.
I love it. We all make them.
I think so as well. Yesterday, I'm talking to a guy who's a very successful business guy. He's telling me he's got a $100 million EBITDA and all this other stuff. And he said, hey, how come my content is not, doing better? How come my podcast is not doing better? And I watch him. I'm like, okay, he's a billionaire. He's done this. He's done that. He's done this. So on everything, he looks good, bodybuilding, physique. I said, you're too perfect. I think the audience likes imperfection. The audience likes to see flaws in people. Passion, realness, vulnerability, sincerity. I think, again, we don't know. I think in 20 years, as this advances, we're going to want to see human error. We're going to want to see that again. Just like today, you see a lot of companies rely on AI on customer service. Some companies clients are like, I don't want to talk to a machine. I want to talk to a human being. I want to talk to somebody with service. So anyways, we'll see what happened with this. I'm just wondering sometimes where you're at with it.
Yeah, I feel the same way when I get an email in, and it's so obvious when it's AI generated. I crave the real, authentic email. Mm-hmm. It's not AI generated, right?
Yeah. When we set out to create a shoe that blends comfort, function, and luxury, we had the choice to make it fast. We had the choice to make it cheap. We chose neither. Instead, we chose Tuscany, Italy. We chose true Italian craftsmanship, each pair touched by 50 skilled hands. We chose patience, spending 2 years perfecting every detail, and we chose the finest quality at every step. Introducing the Future Looks Bright collection. Not rushed, not disposable, not ordinary. Rather, intentional, luxurious, timeless. If you enjoyed this video, you want to watch more videos like this, click here. And if you want to watch the entire podcast, click here.